In this question, it is given that if the shortest distance between the lines this and this is 6, then the square of sum of all possible values of lambda is dash. You have to fill in the blank. Before I do this question, first I will tell you the formula for finding the shortest distance between the two lines when the lines are given in symmetrical form. It is clear that both the lines are given to you in symmetrical form. Also note that in case if one line is in symmetrical form, other line is in unsymmetrical form, the best way is different from the way which is going to be used in this. And if both the lines are in unsymmetrical form, then again the procedure for that question is also different. Agreed, the formula which I am going to use in this, that can be used in other two questions also, but using this formula in the other two forms will be too much lengthy. Therefore, the best way of doing this question is not the best way of doing the question in case of both line in unsymmetrical form or one line is symmetrical form, other line in unsymmetrical form. But presently, I'll be going in the detail of finding the shortest distance between the two lines when both the lines are in symmetrical form. Suppose one line in symmetrical form is x minus x1 upon a1, y minus y1 upon b1 equal to z minus z1 upon c1, and other line in symmetrical form is x minus x2 upon a2, y minus y2 upon b2 equal to z minus z2 upon c2. Remember that shortest distance between these two lines is given by the formula determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1, b1, c1, a2, b2, c2 whole upon under the root first one with the help of these two, a1, b2 minus a2, b1 whole square. Then these two, b1, c2 minus b2, c1 whole square plus the last one, a1, c2 minus a2, c1 whole square, and mod of this also, because distance cannot be negative. In this question, it is given that let the set S equal to, because this question may be negative also, hence we have to take mod also. And now before using these two lines, first I will have to write these two equations in the formula form. That is, this will be written as x minus root 6 by 2, y minus root 6 by 3 equal to z minus root 6 by 4. And the second line will be x minus lambda by 3, y minus 2 root 6 by 4, z minus 2 root 6 by 5. And let me write determinant first. Denominator I will be calculating separately. Numerator is lambda minus root 6 and 2 root 6 minus root 6 and minus 2 root 6 minus root 6. Here 2, 3, 4 and 3, 4, 5 are there. This is equal to lambda plus root 6 and minus 3 root 6. 2, 3, 4, and for writing the third row, I'll be using the property R3 changes to R3 minus R2. Hence, I will be getting 1, 1 and 1. And to simplify it further, we use the property R2 changes to R2 minus 3 R3. This is equal to 3. Lambda plus root 6 and minus 2 root 6. Here I will be getting minus 1, 0 and 1, and 1, 1 and 1. And now use the property that C1 changes to C1 plus C3. I will be getting lambda minus 2 root 6, 0 and 2, root 6, 0 and 1, minus 3 root 6, 1 and 1. And now let us open with the help of second row. I will get 2 root 6 minus lambda minus, that is 4 root 6 minus lambda. And now to find the denominator of formula of shortest distance, it's clear that that will be under root 8 minus 9 whole square plus 15 minus 16 whole square plus 10 minus 12 whole square, that is, this is equal to root 6. Hence we have found that numerator of the formula of shortest distance has this value and denominator of formula of shortest distance has the value root 6. Therefore, according to given condition that the shortest distance is 6, I will say shortest distance is mod of 4 root 6 minus lambda upon under root 6, and this is given to us as 6, that is 4 root 6 minus lambda mod is equal to 6 root 6, that is 4 root 6 minus lambda equal to plus minus 6 root 6, that is the value of lambda r minus 2 root 6 and 10 root 6. Then the square of sum of all possible values of lambda. Square of the sum will be 8 root 6 square, that is 384. Hence the answer to this question becomes 384.